In this video, we'll be talking about what photogrammetry actually is, a bit of an introduction to it. And we have a number of different types of photogrammetry. In essence, one of the main things that we use photogrammetry for is creating 3D models from 2D photographs or collections of 2D photographs. Now, these 2D photographs are taken from different positions and poses, so position and orientation, and they need to have a fair bit of overlap between the different photographs so we can actually join them together and look for common elements between those different photographs. Normally, we're not just dealing with two photographs, for example. We're dealing with many photographs to create a picture, a 3D picture, just like the one above, of what that particular object or building or structure or aerial area that we're surveying looks like. Now, our software analyzes differences and commonalities between these photographs and allows us to create this 3D model. And these 3D models can be quite accurate, and we can use them for measurements, for example, looking at how far objects are away from each other, or doing 3D reconstruction of things and even 3D printing them, for example. Now, there's a couple of different types of photogrammetry. We've got our close range photogrammetry, where we've got a mobile phone or a handheld camera that we can use, or a special 3D camera. There's a few different ones on the market that allow us to take pictures of an object or a vehicle or a house or something like that, that we're looking at closer things. Then we have aerial photogrammetry, where we essentially use aircraft or drones or something like that to get images from the sky. Each of these different applications has different uses, and it really depends on what data that we want and the size and scale of the thing that we're trying to analyze. So firstly, for the close range photogrammetry, here we have one of the Matterport cameras, and one of the things with this camera is it has three different cameras all taking pictures from a slightly different pose. They're a different position and a different orientation with respect to one another. But it's a fixed orientation. So that can be helpful as it processes the data. Our accuracy depends on a number of different things. For example, our camera resolution, the amount of overlap that we have between our photos. It also depends on the number of photos we have and things like the surface of the image. Some surfaces have very few features, and it's harder to do matches accurately between different images. Our image quality, for example, if we've got some vibration or something in there where it's shaky and we've got some blurring. Our camera calibration are also important considerations. In this case, our camera calibration between the different cameras, but also our lens calibration of how flat it is, or do we start having like fisheye effects or some distortion in our lens. Those distortions make it harder to accurately match features between photographs. So there's a lot of different applications for this close range photogrammetry. For example, in a heritage or cultural setting, we might be trying to take pictures or create 3D models that we can display somewhere in a museum or something like that of some cultural artifacts or something from an archaeological dig that's very, very old. We might be doing forensic investigations that you may have seen this sort of thing on CSI, where they can walk through and do like a 3D reconstruction of a crime scene and where things were and measure bullet trajectories and things like that. The places we as engineers would use them more often is in doing industrial inspections, doing condition assessment, looking at an object from a number of different viewpoints, and maybe even recording how those viewpoints or that object degrades over time as it's faced with various elements or harsh treatment within the environment. Another place that photogrammetry is used in a non-technical sphere is in real estate. Real estate agents are always looking at new vantage points and ways to show off a property. And so one of the ways they've done it is using photogrammetry, not just taking photos within a house, but creating these 3D walkthroughs that you can actually look, because these photos have been stitched together. And here's an example of one of these above, where you see this 3D view of what the house looks like and get a bit of a feel for it. And that brings us then to aerial photogrammetry. Here we're basically using a UAV of some kind or another, commonly a quadrotor drone, but not exclusively, and we'll talk about that later on in the session. We're taking hundreds or maybe thousands or tens of thousands of photographs We want to stitch them together. We want to have a fair bit of overlap between those different photographs and create a 3D map that, if you think about what we have on Google Earth or something like that, those photos were taken from satellites a long way away. Here we're trying to take pictures of a whole lot smaller, a whole lot finer detail, because we're much, much closer. And we're getting detail down to like a centimetre level, or even better, depending on what sort of height that we're dealing with. This isn't a brand new technology. People have been taking photographs from the air for a long time, and even using things like balloons and taking photographs from balloons. One of the places this is played out is in wartime, and trying to analyze infantry troop movements and where artillery's been based, and studying things from the air. In the last couple of decades, drones have become an important part of this in terms of surveying. There's two different systems that are used. We can use a metric system, or we can use an interpretive system, depending on whether we're more interested in the topology of where the hills and things are, or we're interested in dealing with the actual coordinate systems and georeferencing this to some sort of other map. We've got computer software that we use for two different applications here. One application is actually designing the flight path of where these drones are actually going to fly, where all the pictures are going to be taken, because we might have hundreds and hundreds of pictures, and you don't really want to sit there flying your drone and stopping it every couple of meters and taking a picture. So that's one application of the software, and the other application of the software is stitching these all together and creating our three-dimensional model. Now, there's lots of applications for this aerial photogrammetry. In an engineering sense, surveying and construction are main areas that we'd use this. Actually looking over a whole site, being able to plan out that site and creating an aerial 3D model, because remember, we're getting significantly higher resolution than we would with our satellite imagery. We can also do imagery in different spectrums, not just the RGB, red, green, blue visual spectrum that we can see, but also, for example, in a thermal spectrum where we're looking at thermal imaging, for example. Likewise, looking at land surveying and looking at earthworks and looking at how they change over time, for example, to ensure that, yes, what had been planned has actually been done to the right standard. So there's lots of engineering applications for photogrammetry and for looking from above with this aerial photogrammetry. I've mentioned the construction applications, likewise with mining, about planning mines, surveying mines, looking at development or growth of mines over time. Agriculture and forestry are some other areas. We can use, for example, near-infrared cameras to analyze plant health from the sky. We can use that also to look at, for example, crop health. There might be some patches within our crops that are not doing as well as others, or some that are doing better than others. You can use this to find sometimes burst pipes and things underground where you have a particular patch that's much greener than the rest of it. We can use it in forestry management to look at and manage the growth of trees, look at how they're growing, looking at fire paths and things like that, and assessing damage after those sort of events. And I already mentioned military intelligence, which is one of the key areas that drove aerial photogrammetry in earlier days. Being able to understand where troops are, where artillery positions are, all of those sort of things, aerial photogrammetry allows us to do.